Welcome to Chapter 2 in Nutrition. This is Dr. Jenkins, and this chapter is all about guidelines. We aren't going to get too far in the weeds about what's the specific amount of grams RDA for carbohydrates, what's the specific RDA for grams of vitamin C, what's the upper tolerable limit for vitamin K. We're not going to get that far in the weeds. But we have to have some kind of tool set or some type of guideline, so at least we have some idea of what we should be eating and how much. So here we go. This is basically just what I said. I know that I'm just recording, so I'm just going to keep talking. Thank you. So I know it might seem kind of boring, but stay with me. It simply is a way to give us some kind of guidelines with a smiley face. All right, we're going to start off with some true and false. Is it true or false? All packaged food must contain a food label. Well, you could look to the end of this presentation, but I'll tell you. The answer is yes. All packaged food, which we'll talk about. The FDA has the ability to order a recall on a specific food if it's found to contain contaminants. We're going to come back to that at the end. Foods have always had a label on them? No, of course not, but they have for a long time. To be healthy, adults need at least 30 minutes of physical activity a day. We're going to find out. Is one serving size of pasta 1 cup? We're going to find out. And is the government still using the food guide pyramid? We are going to find out. Thank you. I bet you can't wait, huh? Yes. Here's our outline. Again, we're not going to get in the weeds too far. And again, I apologize for the background noise. Someone on our custodial staff was coming in and it was very nice of them. So let's just jump right in, folks. Okay. You're not going to have to know everything, but what you'll have to know, I'm going to circle, highlight in red. So one way that we can provide guidelines for what to eat is through something called dietary reference intakes, DRIs. This was established by a reputable source. It was developed using research, which is good, and it is updated, okay? You're going to have to know some of these. You're going to have to know the energy recommendations. You're going to have to be able to define RDA and tolerable upper intake level. All the rest here is extra. Don't be confused. We're just going to go with some specific stuff. Okay. There is something called an estimated average requirement. You do not need to know this. These were established as certain goals for nutrients that inevitably met about 50% of the population. But it's not great because it only meets about half of the population's needs. Here's the EAR. Okay. What we prefer to use is something called the recommended dietary allowance. We like this because it meets almost all of the population. How this works is they set these recommendations a little bit higher. I mean, if we just took the mean or the average for everybody, it would be too low for half the people. So don't worry about these details too much. All I'm saying is that the RDA, which you may have heard of, but even if you haven't, we're going to start to see it now on some labels of food. The RDA are recommended intakes of nutrients that meet almost all of the population because they are guidelines that are set a little bit higher than just the mean. And that way, they will meet most of the population. This compares the EAR to the RDA. You don't need to know this graph. The most important thing is that we like the RDA because it meets almost all of our needs. Here are some examples. Breathe, everyone, breathe. You do not need to know all of these. I'm just giving you an example. So, we might see some RDAs for carbohydrates, protein, RDA for what else? Well, that's all this has so far. But I can look down, I can find my age. Oh, I like this big chunk, so you don't even know how old I am. And I can find, based off of that, I would need about 130 grams of carbohydrates per day. You don't need to know these, I'm just giving you an example. You don't need to know this, but I would like you to know, in general, what this is. Tolerable upper intake level. This is the highest amount of something that can be consumed without harm. A lot of times we like to utilize this with vitamins and minerals, because it's possible, if you have too much, to develop a toxicity. And that's bad. Sometimes we can take in some extra. Vitamin C, oh, it's good for you, right? Yeah, vitamin C is good for you. But if you take in 5 times what you should, according to the RDAs, there is a point where it could be too much and our body cannot handle it, and it could have some negative effects. So it's good to have, particularly for these vitamins and minerals, a stated amount that would lead to toxicity, a tolerable upper intake level, the highest you can take before it causes harm. Here are some examples. You do not need to know these, just giving you some examples. I mentioned vitamin C. Let me give you an example. So let's go to, these are young people. I just realized that. I apologize. So these are young people, right? Just to give you an idea, the normal amount of vitamin C is about 75 to 100 milligrams per day. Let's just take 75, right? So you would have to take quite a lot more than 75. So in an everyday diet, you're not going to be at risk for having toxicity. But I'm just pointing out there can be a point where our body can't handle it, and it could become toxic. All right, there's another way that we can look at this. So I'm just adding in the arrows because they came as blocks. The things that we just talked about were the DRIs, and the daily reference intakes that I had you know something about were the RDAs, recommended daily allowance, because that meets 97 to 98% of the population, and then the tolerable upper limit for vitamins and minerals. Another way, so there's different sets of guidelines we can use. Sometimes using one or the other, there's really no difference. One is not necessarily better. Another way we can do it is by something called the acceptable macronutrient distribution ranges, the AMDRs. Instead of looking at how many grams of each nutrient, this looks at percentages of each nutrient from your whole diet. I've got too many words on this slide, so just follow along with me. You don't need to know the estimated energy requirement. Don't worry about that. I want to talk about the acceptable macronutrient distribution ranges. It's a mouthful. AMDR. Instead of doing grams of carbs, fat, or protein per day, we can use percentages. For these, my friends, I would like you to know the specific percentages. I'm going to drill these into your head over and over and over and over again. Are you ready? Of our whole diet, somewhere between 45 and 65% of it should come from carbohydrates. For fat, somewhere between 20 or 35% of our diet should come from fat. For protein, somewhere between 10 and 35% of our diet should come from protein. What's nice about these is that they're ranges, so we can still find a little bit of specificity. For example, let's look at the carbohydrate. Somebody who's a diabetic or a couch potato, maybe they're going to only need 50% of their diet from carbs. Well, what if we're talking about a marathon runner? They're probably going to need much more carbs because they're going to burn more carbs for energy. So maybe they need 60% of carbs. So we can find our range individually within there. What do you notice from these? Well, I notice that what do we need the most of? Carbs. I know in the last 30 years, carbs have gotten a bad name. Don't eat bread. Put your burger on a bed of lettuce. Well, my friends, we need carbohydrates. Just not too many of them. And it's best to choose whole grain options, less added sugar. But this idea that we want to really, really limit our carbohydrate intake, it's not healthy, folks. Because carbohydrates, that's a big energy source for our cells. So if we're not bringing enough carbs, our cells are not going to have as much energy and they can't do their job. All right, cool. So make sure you know all three of these specific percentages. Okay. I've already given you examples of these. A marathon runner will require more carbs. Couch potato will require less. So these are examples of how we might pick percentages from those ranges. I'm not going to ask you this specifically. I think it makes sense, the idea. A diabetic requires less sugar and less fat. A weightlifter requires more protein. So we can tailor these to our individual needs, but still, almost always, fall within those percentages. All right. Let me just check ahead. Okay. In a minute, we're going to, well, not in a minute, later this chapter, we're going to be looking at the nutrition label. And I just want to point out, on the nutrition label, all of these values, they do give us percentages, right? But I want to point out something. These are the percentages based on a 2,000 calorie diet. So when you read the fine print, and you should know this, and these nutrition labels, they're standardized. So every nutrition label has the same format and has to include similar information. And you're going to see these percentages, but they're not the same percentages as these. They're not. These are percentages of this food based on a 2,000 calorie diet. So it might work for you if in fact your needs are 2,000 calories, or it might be a little bit too low or too high. So while it gives us an idea, it's not necessarily based on you. All right, here's a summary. Let me review with you what you need to know. Know the definition of the RDA, the recommendations that meet most of the population, the tolerable upper intake level, I always mess up that word. It's the highest amount of a nutrient, particularly vitamins and minerals, that could be consumed without harm. And then we talked about the AMDR ranges. You should know all of them. Okay? Trying to be clear, everyone. Wait, there's a lot of information. I don't expect you to know all of it. That would be kind of ridiculous. So I'm trying to pick out the most important. All right. Couple of things I want to say about these recommendations. Anytime we talk about recommendations, I got so excited I misspelled the word. Let's try it again. Recommendations. Couple of things here. Guess what? Moderation is key. Not going to meet it every day. What matters is over time. Yes. Okay, first thing, moderation. I'm not sure who you may have heard things from about nutrition. Anybody that I respect in terms of nutrition has talked about moderation. So it is okay to have a cookie once in a while. I know for me, maybe this rings true for you. If I don't have something sweet every once in a while, I'm just going to eventually binge. And that's not good. So it's all about moderation. Similarly, it's really hard and probably not necessary to eat only healthy foods all the time, no matter what. Let's be honest, sometimes we're traveling, so it's easier to pick up something on the road. Sometimes you go to a party and there's cake. So it's all about moderation. A little bit of the bad, mostly the good. Furthermore, some people get caught in the trap of comparing what they eat to the requirements every day. And one day they're a little bit low on protein and they freak out. Well, no need to freak out, everyone. Every day you're going to have some slight variations unless you eat the same thing, and that's not good either. We like variety. So one day you might be a little low on this, a little high on that. The next day you might be high on this thing but low on that. What matters is how your actual intake of nutrients compares to recommended over a long period of time. Good stuff, everyone. Okay, now how are we going to apply them? All right, there's other ways that we try and have these guidelines. These other guidelines are meant to be a little bit more user-friendly. All right. There are these things called Dietary Guidelines for Americans. And there's the MyPlate. I believe there's a newest one since then. I forget the year. But the point is, and I'm not going to get caught up in these details. All I'm saying is there's some other guidelines that are meant to be more user-friendly. And these are more or less set by the government. And the government utilizes academic and professionals to make these recommendations. Okay, one of them is the Dietary Guidelines for Americans, and the other is MyPlate. Here are some of the dietary guidelines, and it's user-friendly, right? You don't need to memorize these. Just have a sense that they're basically statements. So it's not like they're telling you how many grams of each protein, carbs, and fat you should have. These are more general statements about healthy eating. Of course, you want to balance the calories to maintain weight. You want to reduce certain foods. You want to increase other foods. So instead of focusing maybe on grams, this could also be a more user-friendly way to try and help someone be guided in terms of what they should eat. Also, these guidelines, there's updated ones out, talk about healthy eating patterns. As I just said, moderation and how things are over time, not just every day. And it just talks about these statements that are good for health. Then there's MyPlate. It used to be the 4 food groups, then it was the food guide pyramid, and now it's MyPlate. It's oh so exciting. MyPlate is really a visual. So it's a visual, easy to use set of guidelines. So instead of being like the RDAs, where it gave you how many grams of this and that you need a day, instead of being like the percentages that said, well, you should have 50% carbs, 20% protein, 25% fat. Instead of being that, or instead of just being some general statements, this is a visual. The idea is to have a helpful visual to help you with guidelines for what you should eat. In this visual, I am going to point out a couple things. It says that fruits and vegetables should make up half of your plate. Look at this, half. And there's other things, but that's what I want to point out. So one of the visual takeaways from the My Plate, as set by the U.S. government, fruit and veggies should make up half of each plate. And that could mean breakfast, lunch, dinner. May not be the truth for every day, but over time, that's what they're saying is the healthiest and best for your body. I mean, think about it. If we think about most American plates, especially if you go out to eat, what's going to take up most of the plate? Yes, that 12-ounce steak, baby. So this really goes in contrast to what we get a lot of times when we eat out. So if one could just improve their fruit and veggie intake, they'd be doing better. All right. My Plate also has a website you can go to. So you could go to myplate.gov and you could put in your age, height, weight, and it could spit out some more specifics. So you can utilize more of this, more than just the basic visual. Okay. There's other things that you could see in textbooks, like food groups. You don't need to know this. I'm just giving you some other references. Textbooks, websites, they can give you sample meals and snacks. You don't need to know these. I'm just giving you some resources. Here are some ideas for being healthy in your eating. You do not need to know these, but these are some more statements that would overall contribute to a healthy diet. Okay. For this course, we are going to be using the My Plate. There used to be the My Food Guide Pyramid, but we're going to be using My Plate. Okay. Now, we're still talking about guidelines, and as we do this, it's important for us to go over some definitions. We're going to talk about nutrient density, and in that process, talk about empty calories. I don't know why the arrows don't come up. It's okay. You got me. Nutrient density refers to the amount of nutrients in a food relative to that food's number of calories. So it's not just an absolute number of nutrients. You know, we could say skim milk. We could say skim milk has 8 grams of protein per serving, which is 8 ounces. But I could also say, look at this American cheese. We could have American cheese that was also 8 grams of protein per serving. So that's just looking at the number of grams of protein. When we talk about nutrient density, we're relating those nutrients relative to its total calories. So the skim milk, let's say each serving of skim milk has 100 calories. Each serving of American cheese has 175 calories. So we can see which one is more nutrient dense. There's the same amount of protein, but because the skim milk is only 100 calories, there's more protein considering its total number of calories. So a high nutrient density food has a high nutrient value with relatively lower total calories. Whereas the American cheese may be a little bit lower in nutrient density. It may have the same or lower nutrient, but a higher caloric value. Does that make sense? So not only does it talk about the nutrients in the food, it's relative to how many calories are in that food. A high nutrient density food has a high nutrients, but it maintains a relatively low caloric value. You get more bang for your buck. A low nutrient density food means you have less nutrients, or maybe the same, compared to a higher caloric value. We can also look at calcium. So if we look at one serving, look, I got the calories wrong. I'm sorry, 100, 175. One serving of skim milk is 86 calories. One serving of cheddar cheese is 170 calories. I wasn't that far off. 100, 175. I was in the ballpark. But look at the calcium. Both have about 300 milligrams of calcium. But because the skim milk has less overall calories, it is considered to be more nutrient dense. Typically, low nutrient density foods have a lot of added sugar, added fat, and are packaged. Higher nutrient density foods tend to be homemade. You could make soup and you would add a lot of nutrient density. The overall calories per serving would probably be less, and you'd be getting a lot more nutrients versus a can of soup. Because it's processed, it's going to have a lot of chemicals, and the process of packaging it and processing it so it can sit on a shelf for months strips away some of the nutrients. I like to pick on Lunchables, and not because you should never eat them, but please never eat them. Don't eat them very often. If you do, there's just such high processing to it. Even if you buy turkey from the deli, you're going to be much better off than in a Lunchable. Here's a Lunchable, right? There's a lot of fat. And let's face it, when you eat these Lunchables, and I've only seen people eat them, of course, would never have one myself. There's not really that much in there. A lot of it's just packaging and plastic. 15 grams per serving of fat. And then look at the sodium. Somehow this one got moved, I'm sorry. 1,240 milligrams of sodium. That's a lot. That's basically your daily sodium requirement in just that. So because of the packaging, you're losing nutrients and adding a lot of bad stuff. Low nutrient density. It may be high in calories, but it gets the calories from all that extra crap they added, not from actual good nutrients. Now, we can kind of relate this. Foods that are low in nutrition density, low in nutrient density, like the Lunchables, tend to have a lot of empty calories. These are calories added from processing, usually. That Lunchable has so many calories in it because it's processed. But those calories are not nutrient rich. They're empty calories, things that are in there that don't provide your body with good nutrient value. Added sugar is a great example. We look at a can of Dr. Pepper, 8 ounces. Look at how many grams of sugar, and that's added sugar. It's this much sugar just to that small can. Fried foods have a lot of empty calories because there's a lot of oil in the frying grease. Adds a lot of fat, but not very nutrient-dense fat. Okay, so we talked about some definitions. Nutrient density, empty calories. Let's talk about general calorie requirements. Well, I'm X years old, Y weight, Z height. How many calories do I need? Is there one right answer? Of course the answer is no. You can have 2 people, same age, same height, same weight, even a similar exercise level, but 2 people who on the outside look the same can actually have very different calorie needs. So the first way I like to do this is quick and easy. Okay, if you take your body weight, make this in blue, body weight multiplied by, it should be 10, not 100, my bad. Take your body weight and multiply it by 10. I weigh around 150 pounds. Take your body weight, multiply it by 10, which really just means take the decimal over one place, add a 0. Based on this, I would need around 1,500 calories per day. This is what you would need just to keep up with body functions, what we call basal metabolism. In other words, this is the number of calories you would need just for your heart to beat, just for your arteries to pump blood, just for your kidneys to filter blood, just for your organs to work. And I think you might be surprised, it's kind of a lot of calories just to keep your organs going. We're not even talking about added activity, walking up the stairs. Certainly aren't talking about exercise. But this is an approximate measure, and I like it because it's quick and easy. Gives you an idea how many calories about you need just so your organs can work at rest. You could also, now, and if we use this method, we would then have to add on calories of exercise and activity. So if I was using this method, I would say, okay, here's my basal metabolism. I usually work out 1 hour to 2 hours a day. So let's say that that's average of 700 calories exercise. And when I teach, I like to walk around the classroom. So let's say just my activity, walking around, going up and down the stairs to my office, let's say that's another 400 calories. So then I would add that up, 1,500, 1,900, so that would be 2,600. So I would just make a quick and dirty estimation now. I need about 2,600 calories overall. And actually that about sounds pretty right for me, just because I've had practice doing this. But still, most of my calories are just to keep my body functioning. That's absolutely true. You could also look in a chart. We don't like to do that though. We don't like this way because it doesn't reflect everybody. I mean, I could say, oh, I fit into here, and I'm a female, and I'm pretty darn active, 2,200. Still probably a little bit less than I need. This is good to give us ballparks. I do not love these charts, but at least it gives you a ballpark. At least you know you don't need 10,000 calories a day, or you don't need 1,000 calories a day. So it's not all wasted, but certainly not the most accurate. Okay. There are other ways. So once we get to later in this semester, when we get to our chapter on physical activity, I'm going to give you an equation, a really long equation with parentheses and addition, subtraction, multiplication. And that's going to take into account your age, gender, height, and weight. And it's going to give us a pretty accurate number. So there are other ways. That was just 2 ways we could establish a baseline of how many calories we would need. Okay, moving on from odds and ends here, another thing that we should consider is serving sizes, right? When I was talking about the skim milk and the American cheese, I said 75 calories per serving. Well, what on earth is a serving? I'm going to point out a couple things that I'd like you to know. I don't think it's useful to make you memorize everything. I think that would be kind of stupid. But let me give you a couple. I would like you to know 1 serving size for meat or fish is about 3 ounces, which is pretty much the equivalent of the palm of a woman's hand. It is pretty small. So here's a good example. Do you think, especially if you go out to eat, do you think that your meat serving is going to be only 3 ounces? Probably not. I would guess at least, at minimum, it will be 6 ounces. I mean, if I think about, I don't eat red meat, so I forget, but if I remember correctly, if you go to a steakhouse, what's the lowest amount of steak you can get? Maybe eat like an 8-ounce filet mignon, but usually about like 12 ounces? You want to get your money's worth, right? So if you were to eat an 8-ounce or a 12-ounce steak, you would have to take the number of calories per serving times 3 or 4. It's not always bad to bring in more serving sizes, but the calories pretty quickly add up. So you may in fact be ingesting too much. I mentioned at the beginning, what is 1 serving size of cooked pasta? And it said, is it 1 cup? The answer is no, a half a cup. Seriously, pasta, cooked. That's about the equivalent, a pile of noodles the size of a baseball. Now, I do eat pasta. Not very often, but I like rice better. But I will tell you, when I do eat pasta, I have more than just a half a cup. Which again, isn't always bad, but if I'm counting my calories to try and see where I'm at, I might need to double or triple how many calories I'm ingesting because I'm eating more than 1 serving. There's other things here, but I'm just giving you some examples. Know those 2 examples. So we just said meat and pasta. I'm getting nicer in my older age. Okay. And of course, it should come as no surprise that our serving sizes have gone up over time. I have 2 words for you, big gulp. Now, I'm from Maryland, so I know we have many, many more 7-Elevens than you do. We've got big gulps and Slurpees. I think you have a couple, maybe. I'm trying to think if there's a 7-Eleven around here. Cumberland Farms, you know what that is. You got your big Cumby soda. That's way more than 8 ounces. As a matter of fact, 1 serving size would be 6 or 7 ounces. I'm not going to ask you these specifically. I'm just making a point. And again, when we eat out. So here's an example of what 1 serving size of meat looks like. The equivalent, 3 ounces, to a deck of cards or a female palm of hand. 1 serving of cooked pasta would be the equivalent to a pile equal to the size of a baseball. We definitely usually have more than that. Some easy examples, you get a plastic bottle of soda, it's 20 ounces, that's 2.5 servings. So you got to take however many calories or grams of sugar and multiply it by 2.5. A Dunkin' Donuts bagel, they are huge, absolutely huge. I have a hard time finishing one. This is actually 3 to 4 times a regular grain serving. And I could go on and on. Okay. Coming closer to the end here, I mentioned food labels. Let's look at it. So indeed, every packaged food must have a food label. And let's try and be simple about it. When we're talking about packaged food, these would be the foods in the aisles of grocery stores. This is where we find the packaged food, the cereal, the cookies, the boxed pasta, the pasta sauce, the canned vegetables. These must have a nutrition label. Since 1920s, pretty hard to believe. So here's where I'm going to better delineate what has to have a food label versus what is exempt. So, okay, must, and this can be a little tricky, so that's why I'm trying to make it easier. Must have food label. Packaged food in the aisles. Of grocery store. What is exempt? Meaning it doesn't have to have a food label. Well, produce, fruit and veggies. You don't see a nutrition label on every banana. Bulk foods. So if you go to a place that has bulk foods where you can get a certain amount of spice or coffee or granola. Now, some of these things you can, sorry for the pause, Some of these things you can get upon request. So even though some of them don't have to have a label on them, if you go to the meat counter at Price Chopper, or the seafood counter, or the deli, you can request, hey, I'd like to have a nutrition label on this Virginia ham, slices of Virginia ham. So let's do it this way, right? Must have a food label, packaged foods in the aisles. Things that may be exempt from having to actually have a label on them would be around the perimeter of the grocery store. Around the perimeter, that's where you'll find the produce, fruit and veggies, the meat counter, the deli, the seafood counter. So I think that's an easy way of thinking about it. The things on the periphery do not have to have a food label, but most of those, they are required to be able to give you the nutrition info if you ask for it. Okay, I'd like you to be able to identify some parts of the food label. There's always going to be the serving size. This is a good old-fashioned mac and cheese box. In this box, if you have the whole box, you're actually having 2 servings. Come on, fess up. You've had a whole box before. I know I have, and I'm not proud of it, but it's true. They'll have the calories per serving, and they'll have some nutrient values, grams of fat, carbohydrates, protein. And remember, these percentages of carbs, fat, and protein are based off of a 2,000 calorie diet. There will be some subsets. They'll break down the sugars into added sugars. These will be added sugars. They'll break down the fat into types of fat. And then they may give you a spattering of vitamins and minerals. They also must include an ingredient list. So we can see an example label here, LA Light Bars, and they'll give you an ingredient list. What I'd like you to know is what is listed first is whatever is present in highest quantities. And then as the list goes on, we get to what's present in smallest quantities. Well, let's look at these LA Light Bars. What's the first thing? Caramel. So there's the most caramel. What's caramel? Sugar. Cooked and burnt sugar. So you might look at these and think, oh my God, they must be healthy. They got a lot of added sugar. How do I know? They have a lot of carbohydrates, most of which are the added sugars. And they list caramel, which is burned sugar, first. So just know what's listed first is highest, works its way down. What's listed last is present in lowest amounts. Look at all that you're learning, everybody. So good. So let's go through an example. I like examples. Let's say that you pour a bowl of Cheerios and you have 1.5 cups of Cheerios. To that, you add a half cup of skim milk. This is another lesson. Sometimes you think, oh yeah, I had some cereal. Well, don't forget, you probably had milk in it, so you have to think of both. How many calories did you ingest? Well, let's look at the label. 1 serving size of the Cheerios is 1 cup. So we had 1 cup plus a half. So we had 120 calories of Cheerios plus a half of that again. So we had 180 calories of cereal, plus we had a half cup of skim milk, which is right here. Did I give the examples? I don't remember. No. Okay. I don't remember off the top of my head, 125 mils. So let's just say, oh, right here, you used half cup of skim milk, 86 calories. So now we used 86 calories of skim milk. So now we did 216 total calories. Do you think this cereal has more or less sugars than most popular? 22 grams of sugar. That's actually a decent amount, but it's much less of the added sugar only 1 gram of added sugar, which means 21 grams is natural, this is going to have less. Particularly their cereals with tons of sugar. Lucky Charms. Come on now, Cocoa Puffs. You can read the rest, but that's a pretty easy example here. So I wanted to give you some examples. We have reduced fat or 2% milk and then non-fat milk. The non-fat milk, because we've taken out some of the fat, has less calories. It's the same serving size. The 2% milk has 5 grams of fat per serving. The non-fat, because it is non-fat, has 0. Same amount of protein, which is good. Same amount of carbohydrates. I like that. Which means that the non-fat milk was able to maintain almost all of its nutrient value, but less fat. All right. We are getting towards the end here. In addition to all this, there's even more we got to think about. Because, food companies will say a lot of stuff on their labels. Now, we just talked about how the nutrition label is standardized, and it looks the same on every food. That helps. That makes it easier for us to understand and compare one to the other. But there's also things they could say on the label, like reduced fat, helps promote a healthy heart, could lower cholesterol. There's all these different things that they can add, or claims. What do these claims really mean? Here is a nice table. You do not need to know all of these. I just like to point it out. Look, in order for a food to say reduced calories, that reduced calorie version must have at least 25% fewer calories than the regular version. So they can't just say reduced if it's only reduced by 10%. I mean, the bar is still pretty low at 25%, but it's there. I would like you to know this one, just to have one example. In order for something to be reduced fat, it has to have 25% less fat than the regular version. In order to be low in fat, it must have 3 or less grams of fat per serving. In order to be fat-free, it can have less than 0.5 grams. So it may not be completely fat-free, just a little bit. Here's an example. I want to test this theory. It is saying reduced fat. So reduced fat means that reduced fat version must have 25% less fat than the regular. Doritos, regular 8 grams of fat per serving, reduced fat 5 grams of fat. Yes, that is a 37.5% reduction. So it does fit into the guidelines. And the FDA regulates this, folks. There's other claims they can make. Lean meat, rich in calcium and vitamin D, added calcium. In order for companies to say this, they have to meet certain guidelines. I've pointed out one example, and that is lean, and I'd like you to know this. In order for a seafood or meat to claim that it is lean, quote unquote lean, it must have less than 10 grams of total fat. It gives you a breakdown of how much of that fat can come from saturated. I just want to focus on the total. So, in other words, a meat labeled as lean can have as much as 9.9 grams of fat per serving. That's under 10, isn't it? And as a matter of fact, most companies are going to want to go right under that. They want you to get it because it tastes good. So you think, oh, it must be lean. Well, it may have less fat than the others, but it still could have up to 9.99999 grams of fat per serving. Let's give an example. Look at this Hannaford, 90% lean. What do we see? Well, look, what's 1 serving of meat? 3 ounces. Boom, got it. How much fat? 9.97 grams of fat per serving. It's not 9.99, but pretty darn close. So it does meet the requirements, but just barely. There's other things that must be defined. When something says it's processed, It just means that compounds are added, usually chemicals, and that's used to alter the texture, make it taste better, or improve the shelf life. This is the only way, by processing, it's the only way that we can have certain foods on the shelf for as long as it can be on the shelf. Refined is really another word for processing. You can read about that, but I'm not going to ask you. But I would like you to know these two. You could have a food item that's enriched or a food item that's fortified. So both of these involve processing. I mean, come on, any packaged food that we get in the aisle, and even in the milk cooler at the back, these are going to be processed. It's the only way that we can get it transported from wherever it came from to your grocery store, and it can be on the shelf for a little bit of time. So it's processed. In an enriched food, they replace those lost nutrients from processing back to original levels. On the other hand, fortified means that they replace the nutrients lost from processing, but they replace them to above the previous level. So make sure you review those. Here are some examples of what processing can do. I want to move on because I want to talk about this. Look, we can see milk, for example. Milk is a lot of times going to have vitamins A and D, and they usually say it's fortified. What does fortified mean? That nutrients lost from the processing are added back in to above original levels. Why do we add extra vitamin A and D to a lot of milk or orange juice? Well, because in this country, we're not good at getting enough vitamin A and D through other foods. Not eating enough fruits and veggies, quite frankly. So a lot of these milk companies, they do us a solid. They add some vitamin A and D to that milk. Okay, we're getting towards the very end here. Thanks for sticking with me. There's also some specific what's called labeling claims. A nutrient content claim, health claim, and structure function claim. Some we've already talked about, but these are categorized. Here we categorize them based off of whether or not they need FDA approval. A nutrient content claim. This is what we've already talked about. We talked about reduced fat. Let me use a different color. These we've already talked about. We talked about reduced fat. We talked about lean. There are guidelines that must be met. They must meet guidelines. This is good. So we can have some assurance. We can have some assurance that when they say low in fat, that it is lower in fat. Then there's a health claim. And this is something you can understand. They make a claim based on health. Helps lower cholesterol. Helps with GI tract movement. Maybe foods with fiber would do that. In order to make this claim, there must be some scientific research and support. So there is some FDA oversight. I would like you to know these specific claims. So a health claim helps improve circulation, lowers cholesterol. The companies have to provide some sort of scientific data. So at least there's some oversight there. And lastly, there's a structure function claim. Look, helps to support a healthy immune system. So they're not saying a health claim where it describes the relationship between the food and health. It just says a structure function claim just tells what it can do for your body. This is not FDA approved. They can't say it treats a condition, but they can say things like help support a healthy immune system. They can say that without any data. Pretty interesting stuff, huh? Probably not, but I'm glad you're still here. Here are some examples. You can read through these, okay? And here's some of the answers that we talked about. Great. Okay, I'm going to end there. Any questions, let me know.